Okay, so I want to warm up real quick. So when you inscribe a quadrilateral in a circle, what happens to the opposite angles here?
They're supplementary.
Good. They're supplementary. They add up to 180, right? So 7y plus 10 plus 5y plus 2, that would be 12y plus 12. If you just go ahead and add those up. So they add up to equal 180. So, all right, subtract 12 from both sides. You get 168 divided by 12. And y equal, yeah, it's been acting crazy today. And then divide by 12, what do you get for y? You get 14. And now the question is, how big is angle A? So plug in 14. So 7 times 14 plus 10. That's 70 plus 28, 98 plus 10. That would be 108. Okay. This next one's got several little steps we got to take in it. Okay, first of all, how big is angle S?
90.
It's 90 because, why? Because this arc, this inscribed angle opens up to this 180 degree arc. And remember, the inscribed angle is half of the arc. So that's that angle is 90. Okay, now we know the value of x to move on here. So what do I know about those three angles in the triangle? They add up to 180, right? So 2x and 3x makes 5x. Then negative 6, negative 24, and 90 together equal what? 60. Okay? So I just added all five of those angles, all three of those angles. 2x minus 6, 3x minus 24, and 90. That equals 5x plus 60. So that add up to equals 180. Subtract 60 from both sides, you get 120. Divide by 5, and you get x equals 24. Now I'm looking for arc SR. So to find SR, I've got to know how big angle P is. So if I take that 24 and plug it in right here, what's 2 times 24? And 48 minus 6? Okay, so that's 42. So this angle right here is 42 degrees. So how many degrees is this arc out here going to be? Okay, good. So what we talked about yesterday. So remember, the inscribed angle is always half of the arc. So that angle 42 is half of this arc, which means the arc is 84 degrees. Okay, today we're going to start talking about tangent lines, okay? I know this is pretty small here. A tangent is a line in the same plane as a circle that intersects the circle in exactly one point called the point of tangency. Good. Called the point of tangency. Which it's just this phrase right here. Point of tangency. Okay, so on this circle C right here, this very first circle, I want you to put a point down at the bottom of it. Put a point down at the bottom of it. And then draw a line where it just barely touches that one point. Okay, so this line that we just drew is what we call a tangent. Okay? It's called a tangent. This line is a tangent line. That's the point of tangency. So that's what a tangent means. It's like it touches it at one place and then it goes off forever and it never touches it again. Have you ever heard the phrase of somebody said he went off on a tangent?
No.
You've never heard? Well,
Yeah.
Some people have heard that. What does it mean when they say somebody went off on a tangent?
Off topic.
Yeah. So that's like exactly what happens here. It touches it at one place, then from there it just goes off forever and it never comes back, right? So that's what it means when you go off on a tangent. You start off on the subject, then all of a sudden you get off of it and you just start going somewhere totally different, nowhere close to the subject, okay? So that's what tangent is. It hits it at one point, and then from there it goes off forever. Okay, now we have what we call common tangents, and that's where two or more circles have a tangent to them at the same time. Okay, so like right here, this is a common tangent right here, because it's tangent to that there, and it's tangent to that circle right there. Okay, this is a common tangent. It's tangent to both of those circles right there. Okay, so right here we're going to draw the common tangents. Okay, so right here is a common tangent. And right here is a common tangent. The tangent that's tangent to both circles. Okay. On this one, how many common tangents could we draw?
4.
4. Right? So you'd have like, here's 1. Here's 2. Here's 3. And then here's the 4th one. Okay, so on these next two, go ahead and draw the common tangents between each of those circles. And that 1A and 1B, draw the ones that are common tangents to those two circles. So on 1A, how many common tangents does this have?
3.
3.
3. Oh.
Okay, whoa, that's terrible. I'm going to cheat here. Let's see. Yeah, you're right. There's 1. There's 2. And then there's 3. All right. How many common tangents do you have on these two circles? Yeah, definitely there's just 1. Something like that. Okay. Now this theorem right here is really the main thing we're going to be using today. It's going to be the main idea of what we're doing. Okay. So in a plane, a line is tangent to a circle if and only if it is perpendicular. There's a key word. If it's perpendicular to a radius drawn to the point of tangency. So the way we know if a line is tangent to a circle or not is if the radius drawn to that point is 90 degrees, if it's perpendicular. Okay, so for it to be tangent, where that radius meets up to that point of tangency, those two lines, the radius and the tangent, have to be 90 degrees to each other. If it's not 90 degrees, then it's not tangent. It may just look like it, but it's not. Okay. So, all right. Now from here to here is 9, okay? How long is it going to be from here to here?
8.
It's going to be 8, right? Because the radius of the circle is 8. So this is 8 right here. Okay? So, and you'll see why we need this in a second, but so how long is this whole segment right here then? 17. 9 plus 8, so the whole thing is 17. This side's 15, and this side is 8. So the question here is KL tangent to the circle? And the way to know if this line KL is tangent to this circle, is I need to know, is this angle right here a 90-degree angle?
Yes.
Okay. And you're saying that because it looks like it. We need to prove that it is.
Oh.
Okay. So the way they have this drawn, how can I tell if this is a 90-degree angle?
They drew the triangle.
Okay, so it has something to do with the triangle.
To know the C or something. I don't know.
Okay, it has to do with C. What am I going to use to test to see if it's 90? Pythagorean theorem, exactly. Okay? Because the Pythagorean theorem only works with right triangles, if and only if type thing. Okay? So what we're going to do is we're going to set these numbers up in the Pythagorean theorem and see if it works. See if it's true. Okay? If it is true, that means it is a right triangle. And then this is a right angle. Okay. So of those three, which one is the C value?
17.
The 17. Remember, the C is the hypotenuse. And remember this because this will get confusing on this. Remember where the right angle is? It's like always pointing towards where the hypotenuse is. Okay? So the hypotenuse is the 17. So I'm going to do A squared plus B squared equals C squared. So type in 8 squared plus 15 squared real quick. What is that? Just type in this whole thing right here. 8 squared plus 15 squared, what is it?
8 squared plus 15 squared. 289.
289. Type in 17 squared.
289.
Are those two equal to each other?
Yes.
Yes, that means that this is a right triangle, which means that this is a right angle, which means that KL is tangent to circle J. So the overall answer to this is yes. KL is tangent to that circle because there's a 90-degree angle there. Okay, on this one's confusing, but this 12 is talking about this whole thing right here. On your assignment, you'll be able to tell because, well, you'll be able to tell what they mean. So that's 12, this is 8, this is 6. We want to know if HG is tangent. So is this a 90-degree angle right here? Okay, which one of those is going to be my C?
12.
12. So 6 squared plus 8 squared equal 12 squared. Is that true? Okay, 6 squared plus 8 squared is what? Is 100. What's 12 squared? 144. Those are not equal. Okay. So this is not a right angle. It is not tangent. So the answer is no. HG is not tangent to circle F. So those are easy to test there. Now what we're going to do is they're going to just tell us that it is tangent. So we're not questioning whether it's tangent or not anymore. We're assuming that it is. Well, they're telling us it is, okay? So it says JH is tangent. So JH is tangent. So that means that this angle right here is a 90-degree angle. For JH to be tangent to G, it's got to be 90 degrees to that radius. Okay, and what we want to do is we want to find the value of X. Bless you. So again, we're using Pythagorean theorem here. How long is the A on this triangle?
Don't know.
A is X, so we're going to have A squared plus, how long is B?
12.
12. So A squared plus B squared equals, okay, how long is C? So it's X from here to here, and it's 8 from here to here.
8x.
Okay, that's what most people say is 8x, but that means 8 times x, and that's not exactly what's going on. There you go. It's x plus 8, right? The whole distance from here to here is not these two multiplied, it's those two added. Right? So C is x plus 8 long. So we're going to have x plus 8 squared. All right? So there's Pythagorean theorem, and now from here it's just algebra solving for x. So we have x squared plus 12 squared is 144. Okay, what is x plus 8 squared?
X plus.
Okay. About to take you back to algebra 1.
X squared plus
It's 5.
64.
Okay, what does it mean to square something?
Oh, you square everything.
It means you multiply by itself. So x plus 8 squared means x plus 8 times x plus 8.
So x squared plus.
All right, how are we going to multiply x plus 8 times x plus 8? There's two ways that I know is taught.
Is it like foil?
The little.
Foil or the box method. Foil or box, okay? I think most of you probably were taught box. Some of you probably got foil. I'm a foil person. I just prefer foil. So that's the way I'm going to do it, okay? So if you've never seen foil, some algebra 1 stuff. Here we go. Okay, so foil, what does the F stand for? First. So first of each one. So what's x times x? It's x squared. What does the O stand for? Outside. So the x is on the outside here. 8 is on the outside. So what's x times 8? 8x. What does the I stand for? Inside. So the inside terms are right here. So what's 8 times x? Another 8x. And then what does the L stand for? The last. So the last there. What's 8 times 8? It's 64. Okay? Now we just need to combine like terms. So there's an x squared at the beginning. Is there any more x squareds? Nope, so that stays by itself. 8x, is there any more just x's?
Yes.
Yeah, there's another group of 8x's. So 8x and 8x makes 16x, and then that 64 obviously has nothing to combine with. Okay, so now I'm taking this and just bringing it back over to here. So we have x squared plus 16x plus 64. Okay, and the way this is going to work, it's going to make this pretty nice and neat here. Okay, so let's get our x squareds together. So I'm going to take an x squared from both sides. So on the left side, x squared minus x squared is what? 0. And x squared minus x squared on the right-hand side is what? 0. So basically they just cancel each other out or zero each other out on both sides. And so the x squared term just goes away. So now we have 144 equals 16x plus 64. Subtract 64. 16x equals 80 divided by 16. And x equals 5. Wait till you get to calculus, my friend. Wait till you get to calculus.
Do we have to take calculus?
You don't have to, but I would recommend it if you're going to be doing any kind of math stuff in college. Get you ahead. I did not take calculus at high school, and I suffered for it.
Wow.
Don't do that. If you're going to do any math stuff, make sure you get calculus. Okay, anyways, next one. So on this one, same thing. We're assuming that the ones that appear to be tangent are, so this is 90 degrees. So this one's a lot easier. What is the C value on this one?
17.
17. So that's going to be my C. So we're going to have x squared plus 14 squared equals 17 squared. So there's not much to this. So x squared plus 196 equals 289. Subtract 196. X squared equals 93. No, it's not 9. Yeah, it is. 93. Square root of both sides. And what do you get? 9 point.
9.64.
Yep. Okay, next one. So how long is it from Q to R? Is X. Same thing as it is from here to here. Okay, now remember again, this is where my 90 degree is. So what's going to be the length of my C? It's going to be X plus 2, right? All right, so A squared plus B squared equals C squared. The x is the A, the 4 is the B, and x plus 2 is the C. Okay, work that one out real quick. So x should equal 3. Okay, the last little thing we're going to talk about here ends up being a really easy idea. So it says if two segments from the same exterior point are tangent to a circle, then they are congruent. So in other words, if both of these tangent segments originate from the same external point, then those two tangent pieces are just congruent to each other, which makes sense. Okay, so on this one, both of these start from point B, and AB and CB are both tangent to circle D. And so since both of those are tangents, those two are just congruent. So you just have them equal x plus 15 equals 2x minus 5. And that's 1x, add 5, that gives you 20.